Using Autodesk Robot Structural Analysis Professional software, structural engineers can model not only buildings, but also large and complex structures, such as transmission towers, bridges, and supporting structures. To begin any of the mentioned structural design projects, the structural engineer defines the analytical model. This model is used to determine how the structure will respond to the loading applied in preparation for building operation. Along with defining the individual bars, the structural engineer must choose the properties of the member being defined. This can be done by selecting among a number of predefined shapes, or by selecting known sections from a predefined user database. For example, steel sections of various sizes are accessible from within the content library and can be selected by country and by section type. Structural engineers can access a rich palette of databases that contains sections and materials that meet different standards. Within the same integrated model, engineers can work with country-specific section shapes, imperial or metric units, and country-specific design codes. The structural engineer must decide on structural support conditions, which include fixed, pinned, elastic spring, and non-linear types. Once the geometry of the structure for analysis has been defined, the next task is to apply loads representative of the loading that will be applied to the structure in use. Before defining the actual loads, it is necessary to determine what type of load is applicable for the individual load cases. A load case is a group of loads that may be applied to the structure. They can be applied simultaneously and in conjunction with other individual load cases. Autodesk Robot Structural Analysis Professional makes it possible to define many different types of loads. Depending on the load duration and type, different natures of defined load, such as dead, live, wind, or seismic, can be created. Structural engineers can easily add, delete, and modify parameters of any defined load case. Various types of loads, including nodal, linear, and planar, can then be applied to the structure's defined load cases. Robot Structural Analysis Professional also makes it possible to determine the self-weight of individual members and to apply other forces, such as centrifugal force, body forces, and masses at individual load points or within the length of individual bars. Before analysis begins, the structural engineer must define the analysis type and analysis parameters for a selected load case. Robot Structural Analysis Professional helps streamline the design process by providing the cladding tool for applying loads. The cladding tool is an auxiliary object used to define loads. Structural engineers can take advantage of cladding when generating bar loads from planar objects and snow and wind loads in 3D geometry. The trapezoidal method can distribute the load from the cladding to all objects located in the contour and plane of the cladding, helping to speed up the definition of loads. Because certain loads may not always exist on the building, the combined effect of different load cases applied simultaneously may be too stressful for a structural member. Similarly, certain load cases may combine to reduce the forces exerted on a member. The structural engineer needs to carefully consider the ways in which load cases are combined to ensure the most burdensome load case scenario is analyzed. Autodesk Robot Structural Analysis Professional allows manual and automatic definition of load combinations. Once the entire structure has been constructed, the structural engineer can verify the model and start analysis. Many different types of analyses are available within Robot Structural Analysis Professional software, including linear static, modal, nonlinear, seismic, and time history analysis. These analyses cover the range of required tests a structural engineer would need to apply during any structural engineering project.